Hello everybody, my name is Dương Tống, and now I'm talking about solar energy powered bicycle for remote power management applications. Next slide. There are three main contents: the introduction, the methods, and the conclusion. Now let's go to the introduction. Applications for renewable energy and wireless network technology, the conventional supervisory control and data acquisition (SCADA) system that employs power cable deployment for remote terminal units, and the data line network between the monitoring endpoint and the SCADA host center can be replaced, taking advantage of renewable energy resources in a given mode of transportation. Environment offers a power source limited by the mode of transportation's physical survival rather than an adjacent energy source. Next slide. The solar energy powered bicycle for wireless supervisory control and remote power management applications. The integration of renewable photovoltaic energy and wireless network technology enables a remote terminal unit located in an open outdoor area to conduct on-site monitoring with photovoltaic power through a Zigbee wireless module, transmitting data back to the SCADA host center without physical wiring. And next is the methods. First, the component used. This slide details the specifications of the solar cells used in conjunction with the electric bicycle. It specifies the Model S type GE 50 watt 12 volts with a module size of 835 uh, multiple 540 multiple 35 millimeters and a weight of 6.5 kilograms. The solar module's efficiency is greater than 16%, with an open circuit voltage (VOC) of 22.38 volt, a short circuit current of 3.522 ampere, a maximum power voltage of 18 volt, and a maximum power current of 2.7778 ampere, with a total maximum power being 50 watt. Next slide. And this slide describes the components used in an electric bicycle. It lists specifications such as a maximum speed of 30 km per hour, a noise level of 62 dB, a rated voltage of 24 volt for the motor. The bicycle's weight at 32 kilograms. The bike's dimensions are given, along with the tire size, 20 inches, and it notes the use of lead-acid battery, 2.36 ampere hour, 0.2 12 volt, a brushless motor type, and features like overcurrent protection, 14 ampere plus 1 ampere, and a rated loading of less than 75 kilograms. Next slide. Uh, the system comprises a sufficient number of solar cells to charge energy storage devices, which then provide regulated power for recharging a lead-acid battery and another battery for the discharge process. The main goal of the energy management strategy is to maximize energy efficiency, enhance device reliability, and extend the operational range of the electric bicycle. The energy management circuit can in the systems provides regulated power to the lead-acid battery. And next slide. The experiments show that using only the battery, the bicycle can travel approximately 66.5 kilometers in summer and 64.4 kilometers in winter. However, with solar cells, the range increases to 94.4 kilometers and 85.9 kilometers respectively. These results demonstrate the capability of the solar-powered electricity bicycle, providing an additional energy source, enhancing travel range and reducing the need for manual energy recharging. Next slide. Uh, on the left is the series connected monitoring block diagram. This diagram likely represents how the solar cells are connected in a series configuration. In a series connection, the current remains the same through each cell, and the total voltage of the system is the sum of the voltages of each cell. This increases the overall voltage of the system, aligning with the voltage input requirements of the energy storage unit or energy management system. And on the right is a series connected monitoring block diagram. This diagram might depict how the solar cells are connected in a parallel configuration. In a parallel connection, the voltage across each cell remains the same, and the total current of the system is the sum of the currents of each cell. This increases the overall current of the system, beneficial for enhancing the rapid charging capabilities of the battery or energy storage unit. Next slide. Next slide. And in the results, this structure is carried on the solar energy power bicycle as shown in by the WSN far end network, monitoring solar energy to transfer the electrical energy storage and the effectiveness analysis. In order to achieve this goal, a Zigbee is attached to a solar powered bicycle and the far end wireless network supervisory system is set up. Next slide. As a result, the user of the wireless network in the parking period can be aware of the data on the amount of immediate solar degree of illumination, the ambient temperature, and electrical energy storage capacity information through the Internet interface. Further experience results will be shown to verify a remote power management strategy for the solar energy powered bicycle with the proposed WSN far end network monitoring solar energy system. Next slide. In conclusion, this study is carried out on a solar energy powered bicycle with the WSN far end network monitoring solar energy transfer to electrical energy storage and its effectiveness analysis. In order to achieve this goal, a solar powered bicycle with a Zigbee attached and a far end wireless network supervisory system is set up. As a result, the user through the the users through the wireless network in the bicycle's parking period may know the data on the amount of immediate solar illumination, the ambient temperature, and electrical energy storage capacity information through an internet interface. And that is all of my speech. Thank you for your attention.